So I showed how to create streams, I showed how to run streams, and how to start working with transformers right here. And then the last key concept that you want to know about Z streams are these run and sync methods. So in the architecture diagram here, I talked about transforming elements or modifying them. And then once you have those, you want to go to the Z sync or the consumer. And this is where all the data goes in the end. So when I come back up here, this is just two examples of the way this could possibly work. So if we start with something like ZS1, this could actually be any of these values up here, but in this particular case, I'm starting with ZS1. I'm saying I want to tap into that stream and I want to print the current element, and then I want to call run drain here. And when you look at the output, oh, that's the reason I chose ZS1 was so it had a finite amount of output. When I call run drain here, that's when everything starts flowing. You could think of run drain as being like a drain in the sink. That's where all the data goes to in the end. But another thing about run drain is that it actually starts the stream running. And I'll talk about that in a future video. But a key here is that when we do this tap operation and print those values, it will print 1, 2, and 3 as the stream is starting to run. And then run drain is the sync at the end. And the key about run drain is that it does not collect any values, so it doesn't consume any memory as time is going on. Conversely, run collect is a different type of Z-sync, and it does collect values. So we have ZS1, we start running it with run collect, and then we map and print line that. What happens here is that run collect is a Z-sync, and it does accumulate the values as a chunk. So you see this output right here. And that's a big difference between run drain, which does not accumulate data, and run collect, which does accumulate the data from your stream. Okay, so those are some of the basics, and we looked at stream transformations and marble diagrams. The other thing I want to mention now are Z pipelines. So the transformations you saw previously, I was using map, filter, take while, and for each, just calling these methods directly on the Z stream value right there. Another thing you can do is a different approach. So when I look at this code, the first thing I'm doing is creating another Z stream from an iterable or from a list right there. So that's a stream. And now the part I really want to look at are these pipelines. So we have a pipeline here, here, and here. A key about creating pipelines is that they're reusable. So let's take a look at the first one before we worry about those types right there. So here I'm creating a pipeline. I'm calling the value double numbers. Its type is the Z pipeline. And what I'm doing in the code here is I say Z pipeline. I want to call map on that. And what this means here is that it's taking in an integer and returning an integer. That's the way you read those two types. And then we have a typical map type of function over here. So in this case, I'm just doubling every number that comes in. So that creates this Z pipeline right there. And even though this is simple, the key about it is that it's reusable, just like a function. Any function that you want where you take in an integer value and transform that into another integer value with an algorithm like this, this is reusable like that. And now we can come back up here to the Z pipeline. So the way you read this is very similar to a ZIO value. And basically we have the environment value here. We have the potential error here. So this is our environment. Any old environment will do. This is the potential error value, and we're saying our algorithm cannot fail. So those are the first two types here and here. The third type is the input type, and then the fourth type is the output type. So our input type is int, and then our output type is int as well. So this one shows map. This one is a pipeline. I'm calling filter greater than 5. So you can see that I'm calling Z pipeline filter, and I'm taking in an int. And this is just a typical anonymous function where you're looking at values that are greater than 5. This type signature is the same as the previous pipeline, and that's because we're taking in ints and returning ints. The third one here is slightly different because it says we're taking in an int and then we're returning a string value. So now when we look at this one, it's a map. Again, we're taking in an int, returning a string, and you can see the algorithm we're using is saying, I want to have an integer n, and then I want to transform that integer n into a string. So we're creating this string right here from this integer value. And the real key about that, again, is just looking at the types and saying our input type is an int, and then our output type is a string. So this example shows the stream that we're creating. It shows these 3 reusable pipelines. So just remember that's called double numbers, filter greater than 5, and then convert to string. And now we want to look at the run method inside of our ZIO application here. So we come over here and we can see 2 different options for using pipelines. So number one is we could say, I have that number stream from the previous slide, that number stream right there. And now what I want to do is use these Z pipeline functions as shown here. So you use the via method right here. So I have the number stream. I want to double the numbers. I want to filter greater than 5, and then I want to convert the results to strings, and I want to print each of those values. And given this input stream of 1, 2, 3, 4, 5, and then doubling those values, you can see that the ones that are greater than 5 are going to be 6, 8, and 10. So this is our output right here. And the key in this that I'm trying to show is one way that you would use Z pipeline values. And again, here I'm using them with this via method. And then these are my Z pipeline values from the previous slide right here. So when I come back here, you see those. Now, option number 2 is that you can create another pipeline from the first 3 pipelines. And to do this, we use this symbol or operator. It's actually a method, but we might call it a symbol or operator. And this operator is called pipe2. It's also referred to as via. But this is a nice way we could say, I want to combine this pipeline with this pipeline and this pipeline. And you create a new pipeline value from that right there. And now to work with our stream, we just say number stream. And I want to use via the full pipeline right there, and then print those values. So in the previous slide here and this slide right here, I just wanted to show how to start using Z pipeline values, how to create them here, and how to use them here. There's 2 more things I want to show you right now. First one is error handling. ZIO Streams does a really nice job of letting us work with errors. So if we have a function like this one called process number, where we're saying I want to have a number n that comes in, and then the algorithm here is going to essentially filter out all even numbers. So it says if n modulus 2 equals 0, then ZIO fail. So this is our error right there, and our error is a string right inside of here. So that's why this value here is a string. So if n modulus 2 equals 0, that's an even number, then fail, otherwise succeed with the original number right here. That's the way this algorithm works, but the key about it is that it could potentially fail, and when it does, it'll fail with a string. So now we have this function here. We have a number stream right here, Z stream 1 through 5 right there. So now I'm saying start with that number stream. I'm going to use map ZIO, and map ZIO lets us map over a stream with an effectful function. So this is going to be our effectful function inside of here. So for every number in that stream, I'm going to call process number. And then just one possible way to deal with errors right here is to use catch-all and say, okay, I got an error. What I want to do is print that error. And then a simple way of dealing with this one is saying, I just want to return -1. You could return whatever number is meaningful here. I'm just trying to keep this example simple. So I return -1. So basically between this code right here and what we're doing right here, every time you run into an even number, I'm going to convert that even number into a -1, and we're also going to emit an error message right here. Then after that mapping process right there, I use run collect, and remember that that's going to return a chunk in the end. So that creates a chunk, and then I flat map that, and then in the end, I just print the chunk like that. So I call that an int chunk right there, and when I print it, you'll see the final results right there, final results, and then the chunk is 1, -1, 3, -1, 5. So as I mentioned, every even number here and here is going to get converted into a -1 value by the process of us catching the possible errors and then transforming those into -1 values. So again, this is just a small, simple example of how ZIO Streams lets us deal with errors. Another great feature of ZIO Streams is resource handling. So in this particular case, what I'm going to do right here is try to create a stream from a file, and I intentionally give that file a wrong name right there. And then I'm going to work with that with the via method, as you saw before. So I'll call UTF decode, which is a method built into Z pipeline. I'll call split lines on Z pipeline, and then I'll tap that. And what this does is gives us individual lines from the file. So now when I'm tapping, I'm dealing with a line. So I'm printing that line out. Then I call run drain here. And then things to note are that I called add finalizer exit right here. And I say when the finalizer is called, print this text right here. And then I also added ensuring down here at the end after the run drain. And then I wrote here cleanup complete. So now when we have this program right here, we're going to try to read that file. And in this particular case, it's going to fail. We know that. So the catch-all is going to run. We take that error and we transform it into this print line statement right here. And then the output we're going to get from this is cleanup is complete. So we see that from the ensuring line right here. we see an error occurred, and then that file name right there, that comes from the catch-all right there. And then the last thing we see is finalizer run, and the exit state is this right here. And that comes from the finalizer right here. So the only thing I'm trying to show in this example, my original code was actually just this from file call, these two via calls, the tap call and the run drain. And then I added this here and this here to show the built-in resource handling that you get with ZIO Streams. Okay, that covers our introduction. And then the last thing I'll say is for more information, just come on over to the ZIO Streams reference page. You can see the URL up here. And this starts the introduction to ZIO Streams right here under that streaming category right there.